This is the second video for the 6-2E lesson on nth roots. Does the cube root of -8 equal the square root? So now we start to see that square root of -8. Let's look at cube root of -8 can be thought of as the cube root of -2 times -2 times -2. Oh yeah, there is a 3 of a kind. They are identical. This is -2. And I would encourage you to try this in your handheld calculator or Desmos calculator just to kind of see that that's actually okay. The square root, which you could put a 2 or not put a 2, of -8, well, we could do the square root of 8, and it previously was 2 root 2. And it doesn't matter if this is square root of -8, if it's easier to think about the square root of -25, that this actually can't be evaluated at this point. Because if we have it be -5 and -5, well, that's not equal. And if we have it equal 5 times 5, well, that's not equal. And so there's no way to get identical factors here and have it equal -25. And so therefore, what we say here is we say no real root. That we can't find a simplified square root for this. No real root. You might also see in the answer key something like no solution, which is also acceptable. You'll see that I say no real root because I like to reserve no solution for solving equations. And if you notice on all these problems on this screen and in the whole lesson, actually, these are not equations, these are expressions. So this is no real root. If you type it in your calculator, it might spit back some sort of error message. Or maybe it tries to evaluate it and give you a non-real answer. And so we'll say that these are not equal. Now, maybe they could have been equal even though they're different types of roots. Maybe somehow the cube root of a number might be equal to the square root of a number, and maybe the radicans are different. Um, but obviously, there's a different process going on between these, even if they were both positive. And the fact that they're negative also hints at some of the things we're going to see, which means that some of the problems today, we might not even need to do them. So we'll need to start to figure out when that's the case. Like on number 12, a square root of a negative number. We don't even bother with this. That's the answer, right? It's a trick question. We can't square root a negative number. So before I even start wasting time factor treeing this, I'm just going to stop there. So then how do I do a cube root of a negative? Because we can do that. If I want to factor tree this, I'm not even going to mess with the negative. I might just carry it over in my answer, probably put it out in front with the coefficient. And when I factor tree this, which I actually have factor tree before, so I know it maybe 6 times 36 is a good choice. Oh yeah, and actually 216 is a perfect cube. So notice though, if I do factor tree, doing it with negatives is just confusing. I'm just going to do it with positives and then make sure I carry over my negative before I forget. In fact, I'll probably do that at the beginning. And so I get -6. And so this gives us kind of a good side-by-side comparison. Cube roots with negatives, we can do it. We carry it over. Square roots with negatives, we don't bother with it. So we might want to catch those before it's too late, or maybe even flag them in the homework assignment before we start doing a bunch of problems, and then spend our time actually doing number crunching the problems that we can actually evaluate or simplify.